Hey math friends. So what we're going to talk about today is one-step equations, and we're going to introduce that by doing something that you guys know how to do very well, is making groups of something to get equal parts. So here I have 3 bags of gold coins, and the total of those 3 bags is here. So these are in groups of 1, 2, 3, 4, 5, and there are 1, 2, 3, 4, 5, 6 groups. So there's 30 total coins in these 3 bags. So I want you to think, how can I figure out how many coins are in each individual bag? I'm going to group my coins into 3 equal groups. Well, let's think about this. Out of 30, how do I get 3 equal groups? Well, I can easily look at this array and I can say, okay, here's a group of 10, here's a group of 10, and here's a group of 10. That's 3 equal groups. So there would be 10 for one bag, 10 for another bag, 10 for the third bag. So I could say in each bag there are 10 gold coins. So now we're going to translate this to some algebra equations. So an equation is different than an expression. In an expression, we just had something like 3p plus 2 or 3p. That's an expression. An equation is 2 or more expressions or 2 expressions that are set equal to each other, or they are equivalent. So you're always going to see this equal sign here. So for this equation, we are using the same thing we had with our coins. We had 3 bags, 3 pouches, and they added up to 30 coins between them. So if I had 30 coins and I split them up into 3 equal groups, what operation is that? What did I do to that 30 to get 10? I divided 30 by 3. And I figured out that each pouch had 10, right? Well, let's think about this. When we are solving a mathematical equation, we're going to use something called the inverse operation. And you may have heard that before. Inverse means the opposite operation. So my question to you is this. What operation is happening here? 3 and p beside each other. What multiplication? I just told you the answer. What operation is that? It's multiplication. So what is the opposite of multiplying by 3? It's dividing by 3, which is what we did. But here's how this goes. I want to get this p, this variable, by itself. So I'm going to divide by 3. 3 divided by 3 gives us 1p, which is here. And then when I have an equation, I have to keep it balanced. 30 divided by 3 gave us 10. So our pouches equal 10 coins each. So, looking at your notes that you copied down, or that you're going to copy down. When we solve one-step equations, we're always going to do the inverse operation. So you look at the operation that's happening in this example. X plus 89 equals 123. Well, what operation is this? X plus 89, it's addition. So what's the inverse, or the opposite? Subtraction. So the goal is always to get our variable by itself. We want to know the value of the variable. So I want to get rid of all the extra stuff. So what I'm going to do in this example, I wrote my equation. I'm always going to draw this separator here. I call it a separator, a divider, whatever you want to call it. And I always draw it right down the equal sign so that I know what I do to one side, I do to the other side, because we have to keep our equation balanced. So we said inverse of adding 89 is subtracting 89 to give us x plus 0, or just x. So I have to do the same thing on the other side. 123 minus 89 gives us 34. So our x is 34. Now, something to remember when we solve equations is always check your work. If I think x is 34, let me plug it back in to this original equation. I'm going to say x is 34, and then I'm going to add that to 89. Does it equal 123? And you can always do the old school math. I know you guys don't love it, but you can do it. 9 plus 4 is 13. 8 plus 3 is 11. Add one more, that gives us 12. So I know my answer is 123. So don't forget, you want to get the variable by itself. How do we do that? We do the inverse operation, and you have to do the same thing on both sides. Keep your equation balanced. So let's look at these two examples here. 12 equals 8 plus y. Okay, what operation is happening here? Addition. So we know we're going to subtract. Instead of adding 8, I'm going to take away 8 on both sides. I draw this equal, kind of like an equal sign if you're adding or subtracting or multiplying. So 8 minus 8 gives us 0. I like to cross mine out so I know it's 0. Bring down your y, bring down your equal sign. 12 minus 8 gives us 4. 4 equals y. I want to make sure I'm right, so I'm going to plug that 4 in for y. Does 12 equal 8 plus 4? Yes, it does. All right, let's look at the next one. W divided by 4 is equal to 12. Remember, this fraction bar is a division symbol as well. So, what is the opposite of dividing by 4? Multiplying by 4. So I'm going to draw this here to separate my both sides. Instead of dividing by 4, I'm going to multiply by 4. Now, 4 over 1 times something over 4. Well, I'm going to get 4w over 4. Well, 4 over 4 is just 1. So my w here is by itself. And then I know that 12 times 4 is 48. So, let's check our work. 12 times 4, 48. So 48 divided by 4. Does that give us 12? Yes, it does. So remember, always do the inverse, then check your work at the end. Let's do some with some fractions, just to make sure we're good with it. F minus 2/3 is equal to 1/4. What operation is this? Subtraction. So we're going to do the opposite of that. We're going to add, because we want to get rid of this 2/3. So this becomes 0. I'm left with F up here at the top. Bring that down and bring down your, and then you have to do the other side. So I'm adding 2/3, I gotta add 2/3 here. When I'm adding fractions, I'm gonna write it down here at the bottom to make sure I get it right, if I can write it correctly. 1/4 plus 2/3. Well, we know that when we add fractions and subtract fractions, we have to have a common denominator. My common denominator here is 12. 4 times 3 is 12, so 1 times 3 is 3. 3 times 4 is 12, so 2 times 4 is 8. 3 plus 8 gives us 11 over 12, so F is 11/12. And for sake of space, I'm not going to check my work, but you always want to plug that in, okay? So if I were to plug in 11/12 for F and subtract 2/3 and find common denominators, would I get to 1/4? Yes, I would. For the second one, 2/5 m equals 6. What operation is happening? A number beside a letter is multiplication, right? So that's multiplying. We need to divide. I want to divide by the same number so that this cancels out and gives me my m, right? So I'm going to divide by 2/5 here. Well, we know that when we divide fractions, we have to do keep, change, flip, right? So I'm going to do keep 6 over 1, make division multiplication, and then flip my second fraction, 5 over 2. 6 times 5 gives us 30. 1 times 2 gives us 2. 30 divided by 2 is 15. So if we were to check our work, I'm going to use a different color here. 2/5 times 15 2 times 15 gives us 30. 5 times 1 gives us 5. So that would be 6 as our answer, which is exactly right. So don't forget, friends, always do the inverse operation. Your goal is to get the variable by itself, and you want to keep your equation balanced. What you do to one side, you also do to the other.